In Chapter 4, Part 6, we are going to review some of the exponent rules, and we're going to look at this first chart, and we have an example. So let's focus on the example first. We have 3x squared plus 7x squared. So when we have like terms and we are adding them together, we are going to add the coefficients, the numbers that are in front of the variables. So 3 plus 7 is 10, and then we're going to have our x squared. So if you think about it, it's like 3x squareds plus 7 more x squareds for a total of 10. So we are adding the constants. So what do you do to the constants? We're adding them. That's the 3 and the 7. And then the exponents, they stay the same. Nothing is changing. So if we take a look at multiplying, we have 3x squared times 7x cubed. So we are going to multiply the constants together. So 3 times 7 is 21. And then we are going to take our exponents, our 2 and our 3, and we're going to add them. So this is 21x to the 5th power. So the constants are getting multiplied. And then the exponents are getting added. The last part of this chart is the power to a power property, and we have 3x squared, the whole thing to the 4th power. So back in the beginning of the chapter, we had said that this is like 3x squared times 3x squared times 3x squared times 3x squared. But if we use our properties of exponents, we're going to take 3 to the 4th power, which is 3 times 3 times 3 times 3, which we will get to be 81. And then our x's, we are going to take the power times the other power, so that's 2 times 4, which is x to the 8th. And if you look, you have 2 plus 2 plus 2 plus 2, which is going to give you a total of 8 x's. So for the constants, what's going to happen is we're going to take it to that power, so take it to that power. And then the exponents, they're going to get multiplied. So we're going to multiply them. In the second chart here, we're looking at subtracting. And I'm going to look at the example first. So we have 3x squared minus 7x squared. Since we are subtracting them, similar to the adding, they have to have the same like terms, which they do. So we're going to take 3 minus 7, which is negative 4x squared. So the constants are being subtracted, and the exponents are staying the same, just like the addition. So for dividing, we have 3x to the 5th over 6x squared. We are going to take 3 over 6 and simplify to 1/2. And then our exponents, the exponent rule for division is that we are going to subtract those exponents. So 5 minus 2 is 3. So it's going to be x to the 3rd power. Back in the beginning of the unit, we wrote out our x's, so there's 5 x's on the top, 2 on the bottom, and we simplified using that giant 1 idea to get 3 x's in the numerator, which are going to stay in the numerator. So when we divide, the constants are being divided, and then the exponents are going to be subtracted. So we're going to take a look at example 83. So we have negative 2 times a cubed times b times 3 times b squared times c cubed. So we're going to take the constants, which is negative 2 times 3, to get negative 6. And now we're going to focus on the a. So we have a cubed, and that's it. We don't have any other a's, so it's going to be a cubed. Looking at our b's, we have a b in the first parenthesis and b to the 4th in the second parenthesis. So we're going to add up those b's, which is b to the 5th. And then our c, we only have one c cubed, so it's going to stay c cubed. So negative 6a cubed, b to the 5th, c cubed. Let's take a look at 86. So we have a power to a power property that we have to take care of first. So everything in this parentheses is going to get raised to the 2nd power. So it's kind of like we have this parenthesis 2 times. So we wrote these out in the beginning of the unit. So you could look at it that way, or you could use the power to a power property. So we're going to take 3 and we're going to square it, which is 9. Or you could say 3 times 3, which is also 9. The x's, we have x to the fourth power, and then we're going to square it. So we're going to multiply those exponents together, which is x to the 8th. Or if you look down here, 4x's and 4x's add to give you 8. And then our y to the 0 power is going to get multiplied by 2, but anything multiplied by 0 is 0. So y to the 0 power would be just 1. So we are going to not even write that. It's going to be represented by 1. The second parenthesis, we're going to do the same idea. This is like saying that you have 2xy to the 5th 3 times, because it's raised to the 5th, the third power. So you could either say, okay, 2 to the third power, which is going to be 8, not 6. Again, 2 times 2 times 2 is 8. We're going to have x to the third power, and if we don't have an exponent, it's a 1, so 1 times 3 is 3, so x cubed. Or you can look, we have 1, 2, 3 x's. And then our y value, we have y to the 5th cubed, so we're going to multiply the 5 and the 3 to get y to the 15th. Or again, you could add 5 plus 5 plus 5, which is 15. So once we took care of all of the exponents, now we can combine like terms. So we're going to multiply 9 and 8 together to get 72. And then we can add up all of our x's, which is x to the 11th, and then our y value, which is y to the 15th power. The last example we're going to look at is number 88, and we are dividing. So we are going to look at our coefficients, our constants, 18 divided by 3. We're going to divide like normal, which would be 6. And then we're going to look at our a's. So we have a to the 7th over a to the 5th. So if we subtract 7 minus 5 is 2, so it's a squared. Our b values, we have b cubed, and that's it. So it's going to stay b cubed. And then our c values, we have 5 c's in the numerator and 1 in the denominator. So if we subtract, we're going to get c to the 4th power. So instead of having to write out all of the a's, the b's, the c's, and then simplifying to make that giant 1, you can use the exponent rule and you can subtract them.